All right, today we're going to tackle a question that sounds incredibly simple, but trust me, it unravels into this absolutely mind-bending journey across the entire cosmos. The question is, what exactly is up in space?
So, let's start with a little thought experiment. Picture this. You're in a spaceship, sitting right on the North Pole. You point your ship up, directly away from the ice, and you just go. Full thrusters in a perfectly straight line. Where are you headed? What's out there?
And the answer, which might just flip your whole perspective, is, well, you're not really headed anywhere specific. Because on the grand scale of the cosmos, the ideas of up and down that we live by every single second, they just don't exist. They're concepts that only make sense because of Earth's gravity.
So if our most basic, fundamental sense of direction is totally useless out there, how in the world do astronomers, or anyone really, navigate through the vastness of space? Well, it turns out we had to invent a whole new kind of map.
Right. The big challenge is finding a new frame of reference, a common starting point that we can all agree on to base our directions. So, what did we come up with?
And here's the answer. It's a concept called the ecliptic plane. You're going to want to remember this one because it's pretty much the most important tool we have for getting our bearings out there. It's this imaginary, flat, disk-like surface where almost all the planets orbit the sun. Probably the easiest way to wrap your head around this is to think of the ecliptic plane as the floor of our solar system. And once you have a floor, defining above and below becomes super easy. It's just straight up or straight down from that flat surface. Okay, so we've got our cosmic floor. Now the fun part. What do we actually find when we look above and below it? What's out there perpendicular to the plane of our solar system?
First off, let's just bust a huge myth right now. That classic idea of space being this perfect, totally empty vacuum, yeah, that's not really true. I mean, it's incredibly spread out, for sure, but interstellar space is actually filled with this thin soup of cosmic ingredient.
And what's really fascinating is that the space above our solar system is basically a mirror image of the space below it. Both directions are filled with the same kind of stuff, tiny traces of gas and dust, super energetic particles called cosmic rays, and of course, lots and lots of distant stars.
So let's take a closer look at what's in this interstellar soup. You've got your basic gas and dust. You have cosmic rays, which are these high-energy particles zipping through space, a lot of them from exploded stars. You've got magnetic fields weaving through everything. And maybe coolest of all, you have nebulae. These are enormous clouds of gas and dust that are literally stellar nurseries, the places where brand new stars are born. All right, we've looked at our immediate neighborhood. Now it's time to pull the camera way, way back, because our solar system, as big as it is just one tiny part of a much, much larger structure. Our home, the Milky Way galaxy.
You see, our entire solar system isn't just sitting still. We are on an absolutely epic journey, hurtling through space in a massive orbit around the supermassive black hole that's right at the heart of the Milky Way.
And the scale here, it's almost impossible to really feel it. We're about 25,000 light-years away from the center of our galaxy. That number is so big it's practically meaningless, but it is a ridiculously long way.
And if that distance didn't completely blow your mind, get this. The time it takes to make just one trip around the galaxy, what we call a galactic year, takes our solar system somewhere between 225 and 250 million years. The last time we were in this part of the galaxy, the very first dinosaurs were just starting to roam the Earth.
So just like our solar system has its floor, that ecliptic plane, the whole Milky Way galaxy does too. It's also a relatively flat disk. And our little solar system's plane is actually tilted a bit compared to the much bigger galactic plane. And we even kind of bob up and down through it over millions and millions of years. Okay, time for one final zoom out. We've gone from our solar system to our galaxy. So now, let's see where our entire galaxy fits into the grand scheme of things, the big, big picture.
This is the cosmic web. As far as we know, this is the largest structure in the entire universe. It's this breathtaking, beautiful network of galaxy clusters all connected by these long, thin filaments of matter. And in between are these vast, nearly empty regions we call voids. This is it. This is our ultimate cosmic address.
And this really brings us to the core idea of this whole thing, and it's captured perfectly in this quote. Though the solar system may seem isolated, it is intricately connected to the larger universe. Our local up and down is defined by a plane, which sits inside a bigger galactic plane, which itself is just one tiny speck in this vast cosmic web. It's all connected.
So,
It's pretty amazing, right? We started with a super simple question, which way is up? And by trying to answer it, we ended up defining our place in the entire universe. We mapped our local neighborhood, we charted our grand tour through the galaxy, and we found our home in this grand cosmic order. It's a journey from a simple direction to, well, a profound sense of our place in it all.
And all of this leaves us with one last, really tantalizing thought. We've charted the big structures and the vast emptiness above and below us, but what have we missed? What smaller, closer secrets are still hiding just outside our cosmic front door, just waiting to be discovered?